Right. So guys, now we're going to see a detail about or a short test of detail about ORM. What is that ORM? Object Relational Mapping. So generally what you do, people, you do connect DB with Python, correct? How do you connect? You have your Python code and you need to import a corresponding library of that particular DB. For example, if it is a SQLite tree, you need to import SQLite tree. If it is a MySQL, then you need to import MySQL DB. If it is Mongo, then you need to import PyMongo. Then what you do through the Python code, you will be executing the exact query. For example, if it is a SQL, you will be inserting, you will be updating, creating, whatever it is. All the structured query language, you are writing it in Python. Exact query that what you execute in the DB, the same query you type it in Python shell. So after that, what you do, you will execute. So basically, you do have two different layers. If one layer is Python and another layer is your DB. So what you do, you just connect this with that. This means Python with the DB externally. So whenever you want to execute certain query, what you're doing, you are just pushing the query back to the DB. The DB will execute the query and it will return the result back to the Python. So what happened? The connectivity happening, the channel is getting open, but it takes so much of time because when I want to execute few queries, example creation of table, it needs to go and connect to the DB first. After connecting, it should create a channel for that. After creating a channel, it will execute the query. After executing the query, it will return the result back to the Python code. Then you need to see the result. So the time is taking too much, and you need to exactly understand or you need to exactly know how the queries need to be executed. So you need to have the knowledge of Python and also you need to have the knowledge of SQL or any other corresponding library, DB, and the way of executing the queries or whatever the command that you're supposed to do. Okay. So now people started thinking that why I should create two different layers just to do the DB activity. What happens if my program code, what happens if my program language itself has a tool which can connect to the DB by itself and it can create or it can update or it can delete. Basically, it can do all the operation of the DB without worrying about the DB queries, DB syntax precisely. So that concept is called ORM. Okay. So this ORM concept is supported by all software languages with different names. Okay. Here in Python, this ORM is supported by a library called SQLAlchemy. So SQLAlchemy is not an inbuilt library. You need to pip install that. So you need to go to command prompt, type like pip space install space SQLAlchemy to make sure that this library available inside your system. If you have a doubt, let me run that for you. Command prompt pip install SQLAlchemy. Make sure that you have a proper bandwidth. It says Mohan, this specific library is already installed in the system, so no need to worry. So what I'm doing, I'm importing that library. From there I'm creating analyze the name of DB. Then what happens, SQLAlchemy is a library which is going to connect your DB, right? So your DB can be anything. It can be MongoDB, it can be SQL DB, it can be Oracle DB, or it can be any DB. Okay. So to connect to the DBs, right, you need to import a library called Create Engine from SQLAlchemy. So from the same SQL library, you're trying to import a function called Create Engine. And Create Engine is not the only command that you're going to use, right? You're going to use table for creation of a table. You're going to use column for creation of a column. And then for each column, you need to set the data types of integer and string. And also at times you may have to use the constraint like foreign key, primary key, unique, not null. Exactly whatever you're supposed to do or whatever the thing that you do in SQL, right? You can get it directly as a kind of attribute here. Look at that. The SQLAlchemy itself has the attribute for table, column, data type, metadata, and foreign. If you need other constraint, you can get it from SQLAlchemy. So basically, SQLAlchemy is a package that contains every activity that is needed for a DB transaction. Okay, starting from the table creation and with respect to all the transactions that happen on a DB. That's what the SQLAlchemy does. Okay, right. So SQLAlchemy is a complete package that contains all the corresponding attributes element that is needed for execution of a DB transaction. Fine. What is first thing? You need to decide with the SQLAlchemy, which is supported for Python or which is part of Python ORM. You need to tell what engine that you do need to connect. So I'm telling that I'm going to connect SQLite engine. Fine. Followed by the DB of that particular engine. So I'm telling that I'm going to create a DB called Networks or any name for that matter. Let me create something like Networks Academy. Okay, so this is the DB. So SQLite is an engine, and inside the SQLite engine, I'm going to connect to this DB, Networks underscore Academy. We already seen in DB with respect to SQLite, it doesn't worry about the DB existence, because in SQLite 3, if the DB is already there, it will get connected. If DB is not there, it will create and connect. In that case, if Networks underscore Academy DB is not available earlier, it will create. Okay, and then I have followed by a few commands called echo is equal to true. Generally, what happened, guys, DB is a kind of query that executed only with a table in databases. So you may not see what is happening in between, right? So just to see what happening between the ORM and the DB, right? Let me put that echo is equal to true command so that it displays the process that is happening with respect to the DB in our shell output itself. Fine. Then you need to create a constructor called metadata. So metadata is a part of a SQLAlchemy, and this is indeed what? A constructor that you need to create, and this metadata will have all the aspect of the execution from the table till the other aspect. So the metadata is a part of all the aspect. Imagine, look at that line number 10. So to create a table, you need to have that object reference of that particular metadata constructor, so that the table will be created in such a way that how it gets created in normal DB. So metadata is a vital part of creating anything. Okay, that's what I create. So metadata engine got created, and then I do create another variable called CONN that is for connecting the engine, because after creation of a table I may have to insert the data. Every time I insert the data, I need to create or I need to connect to the engine, and then I have to do that operation: insert, delete, update, select. So that's what the connection is all about. So metadata is a vital part of any DB execution. It contains all the attribute and all the elements within itself for the proper execution. That's what metadata is all about. Okay, now the first example says I'm going to create a table called 1, and that I'm going to keep it in the name of students. Okay, so look at that. Let me create student. That's what table name is all about. Let that be the object name as well. Nothing issue. Okay, now what happened? I'm going to create a table called students, having the metadata as a part of the table creation, followed by the column ID, first name, and last name. And I'm keeping ID as an integer. I'm setting this a constraint of primary key. What happens when you do the primary key constraint? ID will be auto generated, and it will be unique, and it will be not null, as you know. So after doing all these things, what I'm going to do is that I'm going to create all. This is a command that is part of this metadata. So that's what I'm creating. Metadata dot. That means now this metadata will contain data of all the table creation data. So it will contain the instant of this particular query. And what I'm doing, I'm hitting a create all with this particular engine. What engine? SQLite engine with this DB. So what will happen? The table will be initially created. Let me run this for you. Look at that. This is what metadata. This is what the echo does. It says this is the schema that you created. Create table, and table name is student, and this is the schema. If you remember, this would have been the query that you got executed, or this is the query we might have executed when I directly connect a SQLite. Connection dot execute and this particular table. Now you got to know that how this schema is created. That's what the echo true does. Echo is equal to true means you can see how the schema is created within Python, right? I created. What is the next thing that I have to do after creation? I need to insert some data, right? Look at that. So what I'm doing, I'm taking the student name and I'm trying to insert this function and I'm creating this argument. After that, what I'm doing, let me have this. I'm going to insert with the values. Okay. I'm inserting first name as networks and second name as academy. That means I'm inserting values for my columns of the table. What is the table name? Student. What is the function insert? What are you going to do? Values. So what is the corresponding query when you directly connect with the DB? Insert into student first name, comma, last name, values, networks, comma, academy. This is what you do, right? Same thing, but with a different syntax of SQLAlchemy. That's what line number 22 does. After you created this one, you'll create an object for that insertion object that you execute. You need to execute. This is a common execution query. Connection.execute. Connection is the connection for your engine. Okay. So now an error again. Since table is already created, it is going to execute only this. Question mark is nothing but the following data. Networks and academy will be part of these two question mark, and commit, you know that what is the important of the commit to make the transaction complete. Okay. After insertion, what we supposed to do to see whether the data got inserted, we need to select the data. So let us do that. Let us do that again. System issue, people. I'm sorry. Yes. So student.select. I'm selecting the student. Same thing. Select star from student. Same scenario. And then I'm executing this S. And the result, usually we just use for loop to populate all the data. So when I run, okay, let me create first. This is not needed. So now when I run, look at that. It says this is what the data that I inserted little earlier. ID is 1, which is auto generated because of the primary key constraints. Network is the first name and academy is the second name. Look, of course, when you look at this code, it might seem that it has a bit of a complexity, but it is very easy, guys. When you go for a deeper concept, right? When you want to execute a lot of DB queries using Python, it's always advisable that you use this ORM concept. You need to use this ORM concept just to make sure that you execute stuffs in a easiest way. You execute the stuff in a easiest way. This is what ORM, executing the queries of a DB without even worrying about the DB queries. Now everything is a Python related stuff. Python declaration, class, constructor, so on so. But by the syntax of Python only, we have connected to the DB, we inserted the DB and we selected the DB as well. This is the beauty of this ORM. This ORM of a Python is achieved by a library called SQLAlchemy. So this is the short note, people. Okay, just learn this, and if you feel that you are comfortable with this, then whatever we done on SQLite, you can do the same thing here with this SQLAlchemy. We'll see in some other videos, guys. Thank you so much.